las bandas a la izquierda.
Bueno, ok. Ya, inglés, sí, con la sala.
Well, hello everybody. I'm Hilazo. I will talk about code and those things called humans. I'm a software engineer here at Capside, and let's go. So why humans? Why do we need to talk about humans when we're here programmers? We're talking about Perl and everything. Well, I don't think I need to quote some famous name or scientific study or something to say that code is much more often read than written. I don't think I need any source to find this. But reading code should be should be made as easy as possible. The part which we should optimize more is the part of reading, not the part of writing. So reading the code should be as easy as possible, even if it means making writing it harder. So from now on, when I say the term good code or bad code, I will be referring to code that is designed for this objective, to make it easy to read. So I'm talking about good code, bad code, but what defines the quality of the code? Well, how can we measure it? How can we put in a number? There's this drawing that that I first saw at the Clean Code book, and it's not exactly scientific, but well. Mainly, for me at least, good code is code that is simple, it's obvious, and it's, as a consequence of this, easy to maintain. So we will go in this direction. Why is this important? Well, code that is easy to maintain has less bugs. The bugs that appear are easier to spot and easier to fix. And this, in the end, translates to more time to develop new features, more time for new projects, and this is thanks to the simplicity of the good code. So saying the good code leads us to a good maintainability. The main target is that our code is easy to maintain, easy to fix, to upgrade. And this is mainly the point that summarizes everything related to good code, at least from what we will be seeing now. So how do we achieve this? We have to make the code easy to be modified, easy to be extended, and we can do it with code well structured and following agreed conventions. Code has to be self-explanatory, has to be self-explanatory or at least well documented, so that everyone that works in that code feels familiar with it and doesn't have any problem to understand what he's reading. It's also the part about convention is really important too. It covers almost every detail from where to position brackets, typical tabs versus spaces in Word, naming methods and for naming methods and namespaces. But every little detail is important because the person who will read this code, if the code is structured in a way that it's familiar for him, will be much easier to read, will be much easier to find the point when he needs to make the change. So well, we have been talking about that ideal good code. How do we get there? Good code it's easy to maintain, it's important, it's something that interests the company, and for that we have to refactor. It's It's the main point. As you probably know, refactor is the process to apply a series of steps of little modifications to the code with the main objective of making it a better code without changing its behavior, without changing any of the functionalities, without breaking any test, but with a better result. This result, one of the points of the result could be that the code is simpler, for example. But we won't sit now to refactor all of our code and start writing everything again when we have other things to do. For that, of course, we won't do it, everything at once. For that, we have the Boy Scout rule, let's say. Maybe mainly that when you arrive at one point of the code, you have to modify. If you find there a mess, fix it for the next one that comes behind you. But basically, the next camper will thank you for your effort of refactoring that part, and you mainly have to make find the trade-off between the time invested there and the benefit. The refactor could be in the whole class, could be a whole functionality, could be just a little function, but even if it's only a minor change, when you are improving that point of the code, you have earned the context of that function, of the functionality, of that class, and that then is the best moment to make that refactor, because you know how it works. So if you leave it for later and one day you decide I'm gonna refactor that, you have to learn again all the context that surrounds that functionality. What about new code that we write? The previous point was about code that we exist and already exists and we have to upgrade. But new code basically is the same. Once you get it, that new functionality, that new task, when you get it to work, refactor it. But that affects with the time. There's this little thing called sprints that defines a series of tasks that you have to do, and making a refactor will mess up the planification. So again, you have to balance how much effort you can apply without messing with other things. In the end, as you get used to think on how this code will be read, in the end you will write it well from the start. Well, not perfectly, but those little modifications that will make it easier to read, that will make it more understandable. You will find little patterns, and when you write code from scratch, you will go that way directly. But that's with time. As I said, making a refactor, upgrading and fixing the code, messes with time, messes with planification. So when should we refactor? If we do it before delivering the feature, as I said, we can mess up with time estimations, but that's the best point because you just have the context. You understand that piece of code. You have all you need to do it. After the task is already delivered, you will plan it for the next sprint or some days onwards. Time estimations won't be effective because the refactor can enter those estimations, but you will have to get again this context, fight again against the code to learn. It really also depends on the nature of the company and the kind of business and how mature is the company. there's some kind of business that have value stage, value periods. Mainly that's periods of time where the work to do is not as heavy as others. And e-commerce, for an e-commerce will be the peak of work will be Christmas and holidays, but there will be other months where the work is lower. Then in this valley period is the main opportunity to do these refactors, to fix the code that has been developed during the rest of the year. But not every company has this kind of schedule. It also depends on if the company is a new startup, you are developing a minimum value product for the startup. You probably will end up writing code that just works, that we need to release fast and we will find it later. But you still have to keep it in mind because a huge technical debt, a huge problem in your code will sink you later on. Well, we have talked about what we need to do. We need to do a refactor, when we can do it. Now, what do I change? What modifications I have to do in the code to make it easy to read, to make it better? We start with the main point that I mentioned at the start, making this code easy to read. And for starts, let's look at an example with JavaScript. This is I don't know if it looks like. This is a basic declaration of a function in JavaScript. Yes, a function that returns a string. It's the basic syntax. And this is the arrow functions introduced in ECMAScript 6. The syntax it's beautiful, right? It's more concise, it's more direct. But yet I will avoid using this for most of my code. Even if it has benefits, it's more direct, whatever, I will still use the function statement because it's more expressive. It defines directly what it's doing. Here you have it more compressed, it's more concise, but it doesn't tell you anywhere that it's a function. It doesn't tell you that you're returning something. It's knowledge that you need to have. You need to assume and you need to process when you're reading this code. I would mainly research something like this for inline code or a small callback that I'm going to pass to a filter or a map, something like this. And Perl has something similar for subroutines. In Perl, if you don't specify a value to return, the last evaluated value will be the one returned in the subroutine. And when a developer has to read this, or even the author after some time has lost the context, it's not really clear what was the intention here. And I find this really important. It just takes a few characters to write directly this. I want, even if the functionality is the same, here I'm specifying I want to return this value. The person who will come after and read the code will know what my intention was here, and not consider if this value being returned is just a side effect of I do it purposely. Another example, even with something like this, the intention could be both or returning the value, or that was just the last action I needed to do. I just want to end here, or so. If I'm reading the code and I find this, I don't know which one of the two is the main intention of this code. And this is really, it's important when you have to use it to know which are side effects and which are the main objective of the developer when it was developing. And really, I find this example really important because compilers, transpilers, engines, whatever, they already do a great job optimizing the code for the machines. And we need to make the extra effort, why doing more, not assume things, to optimize the code for the humans. That's why we're talking about this. We need to make the extra effort to optimize it for the person who comes after and reading this, has the intention, has the context that we wanted to use. Also, code that is this easy to read, that you don't have to assume or guess some things, gives a sense of security. If I read this, I know exactly what it's doing. I don't have any doubts of the intention, so I can start working with more security than no side effects will appear or there won't be anything unexpected. So well, basically when you're as well as when you're writing a book or preparing a talk, think as writing the code as if you're writing it for others. You're writing for the developer that will come after you and work with it, fix a bug, add new feature, whatever. But you're not writing it for you. You're writing it for the others that come after. Next step, we have started with trying to make the code easier to read. The next step will be trying to find some code smells. Yes, your code can stink sometimes. Definition of code smell is basically this. It's like Martin Fowler said, it's a surface indication that there's some problem deeper. The code smell, it's not the problem itself, but it's a clue that there's something there that could have consequences. Basically, a code smell is something that is quick to spot, and when you have worked with some, when you have learned to identify them, you are reading the code and you know that there's something there that doesn't really fit. But code smells are just that, a smell. It's not always will be a problem behind a code smell. It's just a clue. For example, a large method, a function that has several lines, it's kind of a code smell because you should really review if you are doing there, if you are handling too many things in the same piece of code. Maybe you can split it or delegate some responsibilities to the part. That would be a basic example. Another example of code smell would be a function too that has a lot of arguments, or some arguments are passed by reference. These are code smells too, because maybe you could handle better these arguments, or arguments passed by reference can be a problem because you are covering what happens to the object when I'm passing there. I need to go to that function, look what's happening there, so I don't have any side effects when I'm calling, because the object that I pass as reference can be modified without me knowing. That's all the code smell that I find it's really obvious, but I find interesting. There's basically, it doesn't look quite there, but it's just a bunch of nested conditions. And this happens a lot, and I really like this code smell, this example, because it's easy to introduce a concept that it's the execution stack that the developer has when it's reading code. When you're a developer and find code like this, you have to start reading each condition, and in your head you have like a stack of everything that's happening in the code. The parameter can be empty, or each parameter is set, checks each condition. You have to start piling stacking in there until you go here. That is the part that really interests you. This function does this. The other parts are your checks that you need to do before getting here. But to get there, you have all this load in your head about the conditions and what lets you get there. And this is a code smell that is really easy to fix. It's, most code smells have a signed refactoring process that fits them, and in this case are called close words, word close, sorry. And basically, those conditions move them to all of them to the first level of indentation, and just if they are not correct, return. Just leave the function. You're not there. You're not interested to keep going. Just go out. What you earn with this too is that the part that you really want, the part that really interests you, that is the logic of that method, it's too in the first level of indentation. You leave that all the stack that you had to keep in your mind, it's gone. You start checks, whatever. I don't care. I just want to get here. You have to be careful with this too, because this could lead to methods that are too large, or if you find that I can't really do this. The method is too complex for me to return here. There's an else or something like that. Well, that's another code smell. Maybe you're doing too many things in that method. You could extract part of it and make it. If you make it, you design the method by this rule, it's easier that it's coupled only to the part of logic that really matters. You're atomizing the logic and just keeping the minimum checks that you need. The concept of the mental stack and of execution, it's not only horizontal, it's not only for indentations, you know. It happens too with nested actions. Basically, which code is harder to read here? We have a method that we pass the result of another function that we pass into parameters and modifying one of them. The other option is you have given assigned these parameters, you have split all the actions that you need to I would say the precondition to this action that you really need. You let all the precondition assigned before that. It's the same concept. Same as with the workloads. When you're reading this code, your mind can directly ignore all of this. But if the bug is not here, but you only need to read the part that's important, the part with the logic, you will skip all of this and go directly to the part that matters to, that is the action you need to do. If you need to really consider parameters, you will then pay more attention here. But basically, the concept is the same. Here you have to file in the stack, in the mental stack, what everything you have to do to get that action. Well, there's this saying too that there's two hard things: computer science, catching validation, and naming things. And we're going to talk about the second thing. Basically, as with the previous example, a good code, it's not only a specification of behavior, it has to tell a story. And the main logic, not the parts with assignations and capturing parameters that were before. The real part the real part that matters, that is this one, has to tell a story. It can be more logic, but if it's well separated from the parameters and all these operations that are not relevant to the behavior, we should be able to read it without any problem. So for this, code should be as self-explanatory as possible. Variables should have names that define what they are. We're not really writing an SMS or a WhatsApp message. We don't have to save on characters. So explain really that you have to read the name of a variable, the name of a method, and know what they are doing, even if it gets larger. just say that we don't care really if we get too long variable names or methods, but don't get crazy yet because we can don't abuse it. In a situation like this, where you are in a package with a let's call notification drawer, and you have a variable that is max number of notifications in drawer, this is unnecessary. You know, you have to name things knowing their context. Where in the context of a notification drawer, we don't need to name a notification drawer, and we can use other words instead of max number of whatever. Size and length are words that mainly mean this in programming in general. So these are really the same thing. It's explanatory that what it contains, but we don't need to write too much. Oh, also, it's really important that when naming and methods, really namespaces, variables, when naming in general and applying semantics to the code, you have to be predictable. That's why it's part of what I said earlier from the conventions of the team. If you always name similar methods the same way, you always assign names similar to the same kind of variables, it's really easy to read the code because you don't have to be translating between contexts, between classes. One has max size, the other has max number of whatever. No, if all of them have max size, your brain directly skips this because it already knows what's there. This is another code smell. It's referred as magic numbers and literals. Basically, magic number is this. What is it? 50? 50 what? 50. Here maybe it's 50 notifications, but there could be another 50 later. That 50 is notifications or it's users or whatever. So just, but we're not optimizing for the machine. That's for a compiler or whatever. Use variables. Use something that is explicative. That defines what the value is. Or even better, I'm a fan of constants. I find constants more robust than variables. They won't lead to problems. If you have a collection of variables for constant values, they can be modified, and I have seen, for example, or maybe I have done too, to have a collection, a hash of strings with a key and a longer value. That is more prone to errors. If the key doesn't exist, it will drop an error. You don't really need a hash for that. Just have a collection of constants. They can be modified, and they won't produce that error. It also the names of the constants don't have to explain the behavior of its content. They have to a reference that tells you what they contain. So if we're taking well, maybe it's not the best example, but don't define a constant with a behavior of a string or a behavior of a value when that value and that behavior could change in the future. If that behavior changes but the value doesn't change, we have to update all the names. Don't name a constant that is called 50 and constant is 50. Using that. But it's more the case for strings, really, for literals. Oh, also this is really, I find this really important. Encapsulation in a function, it's not only, it's great for avoid duplicity, but it's not the only use. Encapsulating in functions a part of the logic or just a condition, a simple function that just returns this condition leads to this, and this in the end is much easier to read than a condition that can become more complex. So I would say don't fear to create functions that are only used once. If that function has its own semantics, if that function gives some meaning to what it contains, it really is worth it to have it there. Well, when it's not enough to name correctly, to have semantics that much, basically when you take certain design decisions or make workarounds for a problem in usual practices, or you make a decision because that point of the code has to be really performant and there's no other way to make it clear, it's okay. Just there, it doesn't have to be that self-explaining. You have a reason, but document it, because the person that comes after, it's if it's not written, or if the code doesn't tell him what is happening there, and you have documented it, he won't know why that decision was taken, and that's really a situation to have, because if you're feeling that of making a change because you don't know why something was done that way in the past, you are not safe enough to update that code or make changes. So well, how can we enforce all of these principles? Just do code reviews and test. White test. I know it's groundbreaking. I just blew your mind, but it's just that. You just have to keep all of this in mind, and as you keep finding it in code, if you keep learning new code smells and finding your own code and code of others, you are really faster in finding these things, and you even detect it before writing. You don't really need to go full extreme programming. You know, it's a good reference, but it's not really necessary. Just doing some code reviews and writing some tests. It doesn't have full coverage. It doesn't have to need full coverage, but it just helps the way. So our code reviews. The purpose of code reviews, which will be it's to check that the code is valid. I think it's more the code review should be to check that the code is maintainable. It's what we were talking at the start. To check the quality of the code. If the code is valid or not, it will crash. We will see it before it should have be seen before, or it will be reflected in the tests. And the code review should check that you are reading code that it's not, the reviewer is reading code that is not it's not okay. And he will, if the reviewer is not understanding a part of the code, that's a red flag. That's a clue that part could need a refactor to make it clear for them. Because now maybe the team has the context of what's happening there, but 1 year ahead it won't be the case. Also, reviews are not only for junior developers. These problems can happen in seniors, and another developer, even if it has the less experience than the one that submitted the code, you can look at things in a different way, or maybe this is precisely the part where it's important. When someone is senior and is used to write code in a way, and for him it's natural, but another person that is in the team goes there and doesn't understand what's happening, that's really a red flag, but because that person will have to maintain that code in the future. Also, as well as reviewing the code, just be sure to share those reusable bits of code that you write, because it might lead to creative discussions, and it might lead to save time for others. And it's as important as reviewing. Also, about tests, specifically unit tests are really important for, or do really help for this. Unit tests can easily report a problem in the design of software. if you're writing code that it's hard to test, that you can really mock all its dependencies of has too many dependencies to mock, or you really can check all of its behavior. That's really a problem. That code is doing too many things or needs too many dependencies. That's a strong code smell that something is wrong. So basically, this gives you a harness of security. Gives you that sensation that you can break things. They are really necessary for refactoring. If you're not really comfortable refactoring code or improving it if you don't have a test behind that ensures you that you are not breaking it. That's why TDD is such a good practice for this kind of writing code. Because if you are refactoring and the test still pass, assuming that the test is good enough to show about them, writing first the test first helps you write code that it's not coupled to things that it doesn't need to do. It's just the minimum logic to pass this test to do what you need to do. And it will be decoupled. It will have the minimum dependencies possible. Because you will mock them before in the test, and it's really a good way to force you to write tests that is designed this way. Still, software design notions should be learned before going blindly to write tests. TDD can really bring you to a good design if you don't know what a good design looks like. You need to have some notions to write a good test that will bring you good code. So to summarize, some takeaways. They are not sorted by size, I promise. But basically, you have to write code that is easy to maintain. Refactor as much as you can, whenever you can. Tell a story with your code. Focus it for someone that will read it after you, not for you, that you are the one writing it. Make the intention of the code clear. That's really important. Look for code smells that will bring future problems or indicate that the code is coupled where it should. Do code reviews and write tests. And basically, write code that you will feel proud if you read it later. Or as there's a saying that I like write code as if the one who will read it later is a psychopath and knows where you live. Also, it's important to know too that as much as I like this way of working, these practices are not really free. You have to choose your battles. You won't always have the luxury of the time or to design a good code and write it as you would want. There's times where you just need to write code that works, and that's fine. You just have to need the experience and focus your mind on that to know when you really need to do one or no, considering the trade-off. And as a final takeaway, so I will give you reference to these two links that both are catalogs of refactorings. This one is from Martin Fowler, the writer of the refactoring book, and has a catalog of basically the refactors that he explains in his book, but more directly explain what changes you have to do to apply this refactoring to one customer. And refactoring.guru, it's more or less the same, but it has the catalog of code smells, the catalog of refactorings, and you can look both ways, and gives you step-by-step instructions to how to refactor one code smell to apply the refactoring to resulting code without breaking anything in any of the steps.
5 minutes?
Yeah, no problem. I'm finished. So that's all. Thank you.
Just a question.
sometimes you ¿Qué?
You go.
Sometimes you write a line of code that you only can understand because it's beautiful, but it's folded, and you want to maintain this line because you are part of this line. How you can make easy for the next human who read, but without changing the code and unfolding your one-liner?
Well,
it's like a good way to do it. Or
I would say that the main problem is that that line is not yours. The line is of the team, is of the product. So it's that one functionality, one task that you develop or one project, or it's yours, and whoever touches it, it's it after. So even if you really like the way you have developed something, because it's like magic. It's just beautiful how much it does in so few characters. It's not worth it the minutes, hours that the person that comes after you will have to spend to decipher that, or even you yourself, if you come there after some time, if you don't remember exactly what technique or what feature you were of the language you were using to code that, it's not really worth it, that sensation. You know, that was the question.
Yeah, no. Sometimes like what I do is I leave a note at the end of the code with the one-liner, and then a reference, a common reference. This can be done in what line? You can see it and enjoy at the end of the code. Here's the human.
But there's two things there. Also, sometimes things like this that are magic or are just a piece of code that is perfect for that context. It's applicable for what I said about extracting a function there. Even if the code there is just one line, it's not self-explicative. It's started to a function that just have that one line, but the name of the function explains what it's doing there. So you later will be reading the code. You will have a line that will be a function code that explains what's happening there. And if you want, you can go to that function and see the details. But at least you have it's like having a comment really, but just it's integrated in the code. Also, when this practice is different for when you are working on code that it's for a personal project, and that when you are working in code that it's part of your team at work or an open source project. When you are developing for a personal project, you're writing code for the machine, basically, because you already understand that code, and you are practicing and learning how to write for the machine. But if you write code together with other people, and they will have to come after to ask you later what's happening there. That's when you really learn to write code for other people, not really for the machine. Because the time that you and the whole team will end with that was really valuable.
Okay. A mí me pasa, pues lo dejo abajo. Nota del director. Aquí tenéis como es como hazme una foto para Instagram.
La sufro.
Nota para el resto de su
Aún la sufro.
Pero a que no ves ahí, hostia. Trae cuando se puede, esto aquí tan bonito pintado. Me pasó un mes de
Ya.
Muriendo la garganta.
Ahora disfrutar de la conferencia.
Ya pasa ya.
¿Estabas nervioso?
¿Eh?
¿Estabas nervioso?
No, o sea, no me has visto nervioso. Si crees que ahora estaba nervioso. O sea, no, realmente no. O sea, simplemente eso. La incomodidad, ¿no? Estar aquí delante, pero
sí, ja és un mes que el dilluns envia el currículum. Bueno,
Yo soy yo.
¿De vaca o de arroz?
Lo siento mucho, pero llamarle a eso leche no te lo acepto, Rael.